The formation of subsoil compaction happens over time as soil health is degraded. Good soil structure as found in nature and undisturbed soil is porous. This is due to aggregates, brittle clumps of soil particles. The porous structure thereof allows for roots to penetrate deep in the soil profile, and it is an environment where soil biology flourishes. Aggregates are made up of smaller soil particles held together by the positive-negative bonds between positively charged cations, particularly calcium, and negatively charged soil particles. Aggregates are further stabilized by plant roots and fungal hyphae, thread-like structures that weave between the soil particles, keeping them together. Fungi also produce glomerulins, a sticky protein that further stabilize the aggregates. However, when preparing a field for agricultural use, all plants and roots, also the fungal components, are removed and the soil structure is disturbed, breaking up the aggregates. With rain or when irrigating, the smallest individual soil particles are washed through the soil profile, segregating the bigger and smaller particles. While the soil structure is still fairly good, crops and fruit trees do well, but over time as more small particles accumulate, subsoil compaction layers are formed. Compacted soil impedes root development that cause J roots to form that cannot penetrate the compacted layer. With poor roots, the tree health also starts to diminish. Water does not infiltrate well in compacted soil, leading to waterlogged soil with poor gas exchange, as well as water runoff between the ridges. With poor water infiltration, salts start building up in the root zone, further impeding root and root hair development. Ultimately, the root zone becomes an unfavorable environment for beneficial soil biology, as all the earthworms have disappeared during this process. In these conditions, crops and trees perform poorly.